This is a problem these days. Problem of having dead people in the classroom. It's a study about dead people in classrooms.
Like me?
I don't know if you understand it. On average, dead students are less likely to skip class than living students, especially on nice warm days. Dead students have perfect attendance, were always in class early, and never left early. In fact, they often stayed long after, never complaining when lectures went ran long. Unlike their living companions, they have less than perfect attendance, were often tardy at times when they were early. They're less disruptive. Their weak point seems to be exam performance, however. First order of business. Nicole would like to know if you're going to teach in the fall.
Oh, I haven't said that.
Said no. Okay, she didn't.
I did actually just saw.
It wasn't even my fault.
Okay, she didn't understand that. Nicole would like to know if you want to teach in the fall.
My daughter's.
How many days is she going to get married on?
Oh my, this is like an animal that's sucking the life out of me. Seriously.
We're talking about Bridezilla.
And when I call her Bridezilla, she's really curious.
Nicole would like to know if you want to teach.
I just got her, not the bomb.
I think that's it. Anyone else?
Yes, I don't want to. That's
Anybody want to teach?
I'd really like to, but
I started in the spring and I trusted it, but I was having
No.
block scheduling and did prep.
Oh my, that's your life is so busy, so interesting. Oh, I see she left her thing on the. You don't want to do it. I want to do it.
okay.
Yeah.
I'd love to, but I don't know. I applied to a couple things for out of the area, so I don't want to tell her I can do it and then get a job somewhere. So.
Well, I think you could say pending. I to be honest with her, I've applied,
Yeah, it's like
and this will give you some kind of a backup. She's there not teaching, kids getting more and more certain things.
yeah, I should probably do like Thursday because the grad class is on Monday.
Why don't you tell her and say that, to be completely honest, I might fail because it would only be because I get a real job or I go to grad school, or both, You guys, no. All right. Huh? Oh, okay. Well, I mean, you can still talk.
I'm having a baby getting ready to cry. You guys should do something. No idea. No.
Yeah, and did you get mine?
No.
Oh, I said, yeah, well, maybe.
Yes.
I can politically correct cardiology. Instead of saying a patient has heart failure, he's inotropically challenged. Poor surgical candidate, cardiac medical therapy enabled. Metabolically different, entropically enabled. Oh well.
You're born this week, right?
What is that?
The annals of improbable research. Okay. So, okay, well, I think we should do it like. All right, you're ready.
Z1.
Z1. Real
Right
math.
now. Okay.
Real math. Okay, now we're serious. All right. We have several things on the agenda. You're going to integrate X times in here. Okay. I budgeted an hour for that. Did you really? No. And you're going to discuss Volterra? Oh, thank God. Look, they can depend on her. Okay, what I had thought I'd do is sort of finish up the official derivation of the Riemann-Stieltjes formulas and then try to prove Lebesgue's theorem from 1902 that characterized the existence of Riemann integrals sort of without any bells or whistles. It's an if and only if. Unlike the Cauchy existence theorem that we have, which is sufficient but not necessary. You like necessary and sufficient conditions, and the Lebesgue theorem for Riemann integration is a necessary sufficient condition. Whenever you have something like that, it's pretty definitive, especially if you have fairly weak properties that are placed on the function to be integrated in. The Lebesgue theorem, do we remember what that is? It's bounded, and the set of discontinuities has measure 0. Then it's Riemann integrable. Not Lebesgue integrable, Riemann integrable, proved by Mr. Lebesgue, Monsieur Lebesgue in 1902. So that was sort of the definitive result. So, Riemann-Stieltjes integration. You say a function is Riemann-Stieltjes integrable. You write this is the R, and very often with respect to the integrator alpha. If what happens? Remember what happens if for any epsilon greater than 0, there exists a delta that depends on epsilon, such that for any partition with norm less than delta, that implies that a Stieltjes sum for that partition with respect to this integrator of this function is arbitrarily close to a limit, which we call the Riemann-Stieltjes integral, or just the Stieltjes. Okay, so what does a Stieltjes sum look like? It's a sum, and we're writing our sums like this rather than indexing, right? So we have a function, and it's evaluated at some xk, and then instead of writing delta xk like we have been used to with Riemann integrals, we write delta alpha sub k, right? And then over here we would write L. If that's true, then L is of course all of this is defined on AB, right? F is F is defined on AB as usual, so this is an integral from A to B of F with respect to alpha. It's very, especially with Stieltjes integration, the variable x doesn't play much of a role. It's just baggage. Technically, that's what we're writing there. So the tradition, sort of the convention, is to just delete the x's. So that's what a Stieltjes integral is. In the event that alpha of x is x, then Riemann-Stieltjes is just Riemann. So if you do the derivations in a more general setting, all you have to do is let alpha, the integrator function, be x, and then everything falls out for the Riemann integral. We showed, I think maybe even it was a week or so ago, that it's possible with the Riemann-Stieltjes integral to have some embarrassing things where you can have an integral from 0 to 1 exist and 1 to 2 exist, but the integral from 0 to 2 doesn't exist. That kind of thing happens when you allow alpha of x to have discontinuities and you allow f to have discontinuities. So the first thing you need to do is to insist that f and alpha don't have a common point of discontinuity. As long as they don't have a common point of discontinuity, that sort of thing can't happen. And you have additivity on the interval of integration. That's where you have that little thing where it didn't even exist
doesn't happen.